Alright, in this video we'll be going over investigation 10.1.2. So here let's do a quick warm-up. We know that for an equation of a circle, in order to shift the parabola, each of the parabolas are going to be backwards. So normally we think of positive on the right, but this time in order to move to the right we're actually going to have to subtract. So like -1, -2, -3, right? That looks good. And to shift it down, instead of subtracting, we have to add, right? So everything's kind of backwards when it's inside the parentheses. Let's do +1, not quite centered, 2, 3, 4. All right, that looks about centered. And now let's go and increase the radius. Again, if I do 2 squared, the radius is 2, 3, 4, 5, and 6. All right, so by shifting the parabola, moving it sideways, up and down, and then increasing the radius, we get it to overlap. All right, let's try shifting this one. I think we're going to move it, let's see, move it right, so -5. Move it up, so -1, and the radius is going to be 2, so twice the size. This one, it shows an X, but this is the correct answer. I think I just typed in the wrong answer key. So again, this one should be correct. Okay, moving forward. Let's see, I'm going to shift to the left, so I need to add to shift to the left. Let's do +7. All right, to shift it down, I'm going to add to shift down, +2. And it looks like this one has a radius of 3, so I'm going to do 3 squared. Okay. So how do we change an equation of a circle to graphing form? That's going to be our focus question. We know how to change a parabola to graphing form by completing the square, and you'll see that it's going to be a similar process for completing for changing a circle. Okay, let's go and do some examples of completing the square with parabolas, because that's going to help us when we deal with circles. So here we have -6x. And to make a perfect square, notice that the -6x, we have to split half of it over here. -3x over here, -3x over here. So you have x -3 times x -3. That's our perfect square. Again, this is a square because it has the same base and height. -3 times -3, what answer should that be here? It's supposed to be 9, right? 3 times 3 is 9, but we only have 2 tiles here. So I need to add 7 more on both sides. Add 7 on both sides. That way I have a 9 here, and I can complete my box. Okay. So now that I have my completed box, I have x -3 times x -3, which is the same as x -3 squared. And notice that here next to the 7, when we added, or next to the y, when we added 7 to both sides, do you see how we have the extra +7 here? That's because we added 7 to both sides here. This is not quite in graphing form yet because everything needs to be on one side. So the opposite of +7 is -7. Move the 7 over here. And now this is our graphing form. So to graph this, again, -3, this is inverted controls. -3 actually means we're going right 3. 1, 2, 3. And -7 is going to be down 7. 3, 4, 5, 6, 7. Right, and so that's our parabola. All right, try the next one. Let's go and rewrite this equation to a perfect square. So we have 18x, so half of it's going to go here. 9x and 9x. Right, and that ends up being x times x is x squared. X times 9 is 9x. Right, but what's supposed to go in this corner here? What should 9 times 9 be? What should the area of this section be? So we know that 9 times 9 is supposed to be 81, but we only have 80 tiles here, so we need to add 1 more to each side in order to complete the square, right? Now that we have 81, we have our perfect square, and you can write this as x plus 9 squared. All right, not quite done yet. Notice that when we added +1 to both sides, there's a 1 next to the y now, and that's because we added 1 to both sides. So to complete the graphing form, we need to move this 1 to the other side. And now we can go ahead and graph, right? So +9 actually means moving left, right? Left 9. All right, and -1, y works the same way we think it would. Down, -1 means down 1. Okay, and let's go over this next one. Here we have -10x, so again, splitting half here. 5x is down here, 5x is over here. So you have x minus 5. All right, 5 times 5 is supposed to be 25, but we have 28 here. So we actually have too many tiles. We need to get rid of 3 of them. So subtract 3 on both sides, and that way we deal with 25. And now that everything in here matches, we get a perfect box. We get a perfect square. X minus 5 squared. All right, and we -3 on both sides. Notice that there's a -3 next to the y now. So to get rid of that -3, let's add 3 to both sides. Add it to the other side. And so to graph this, again, -5 means right 5. And plus 3 works the way we think it would, up 3. Okay, so again, this is completing the square for a parabola, right? Just completing it so that we get the perfect box down here. All right, so let's go and review parts of a circle. Here we have H, K, and R. So H affects the side-to-side shift. K affects the up and down shift. And R is the radius. Okay? And quickly remember that it's going to be inverted controls. So again, for a circle, positive Y, or positive H, you see H is positive, is moving to the left. And subtracting moves it to the right. Adding moves it to the left, subtracting moves it to the right. So it's kind of like inverted controls. Here, positive K moves it down, negative K moves it up. So again, it's kind of backwards than what we would normally think of, right, for a parabola. And obviously the radius, again, I can increase the radius to make it a bigger size. Okay. So let's go ahead and match this equation here. Here we want it to be in the center. So we're going to do, again, to move it right, I'm going to minus 3. And to shift it up, I'm going to subtract minus 1. So now at the center, I see the radius is 1, 2, 3, 4, 5. So it needs to be 5 squared. Okay. When I write an equation like this is called graphing form, or sometimes it might be called vertex form. Again, we can see the shifts here. It's shifting sideways, shifting down or up. And we can see what the radius here. So normally we like circles in the form of this equation so that we can figure out what the graph looks like. But it's not always going to start off this way. So for example, here, can we multiply each of these binomials and figure out what it is in standard form? So here we have x minus 3 squared, x minus 3 times x minus 3. So during our area model, we have x squared minus 3x minus 3x, and negative 3 times negative 3 should be 9 in this corner. Okay, over here, y times y is y squared times negative y down here. And negative 1 times negative 1 is positive 1. So from the x squared from this part, that's going to turn into x squared, x squared minus 6x, because there's 3 here and 3 here, plus 9. So again, that's just from this part. And now this y minus 1 squared is going to be all of these tiles. It's going to be y squared minus 2y plus 1. So these are from squaring the x minus 3, and this part squaring from the y minus 1. It's not quite in standard form yet. We're going to need to simplify a little bit more. So I know that 5 squared is 25. Okay, and here we have a 9 and a 1. So let's go ahead and combine that 9 and 1 to get 10. And to get in standard form, I want to move these to the other side. So minus 25 on both sides. These are gone. And 10 minus 25 is going to be negative 15. All right, so this is the equation in standard form. So again, notice that in standard form, we don't know what the shifts are, and we don't know what the radius is. So again, if we're stuck with an equation like this, it's always nicer to turn it back into graphing form. So that's what we're going to try to figure out now. How can we go backwards? So if I'm starting with this standard form, how can I go backwards to figure out this graphing form? So basically all we're going to do is complete the square twice. We're going to complete the square using the x tiles and complete the square using the y tiles. So here we have x plus 4x. Again, to complete a perfect box, we need to split it in half, 2x and 2x on both sides. Now the x times x is x squared, x plus 2 times x plus 2. All right. So what should go in the corner here to complete my box? Again, this is a 2 by 2 section, so I need 4 tiles to complete my square. All right, let's try the y section. Here again, I have 2y, so I'm going to split it in half, a y here and a y here. So now I know that y times y is the y squared, y times 1 is the y, and 1 times 1 to get this section down here, I need a 1 by 1, which is 1. All right, and finally to get it into graphing form, I'm going to move all the other remaining tiles to the other side. So again, we started with these minus 11, so I need a plus 11 to add it to the other side. So on the right side, we have 16, right? We added these tiles, and then we cancel these out. So these tiles to complete the square, plus canceling these 11. So we have 16 on the right, and we have our 2 squares on the left, right? We have this perfect square on the left, and another perfect square on the left. Okay, so for these squares here, this is x plus 2 times x plus 2, or x plus 2 squared. Oops. All right, and here we have y plus 1 times y plus 1, which is y plus 1 squared. So that's how we go from standard form to graphing form. We just complete the square twice. So after completing the square twice, what does this graph look like? Again, plus 2 means it's moving to the left 2. Oops, sorry, plus 2 means left 2. And plus 1 means it's moving down, right? And this has a radius of, so again, you might think this might be 16, but again, it should be radius squared. I know that 4 squared is 16 because 4 times 4 is 16. So the radius is actually 4. Okay, so that's what the circle looks like. Let's go ahead and do another example. So here we're just using our numbers to figure it out. But here, this might be a good chance to be reviewing our algebra tiles. Tiles can help us visualize what's happening when we're trying to complete the square. So we have our X tiles here in blue and our Y tiles in purple here. And again, if I want to complete a square, notice again, I'm going to split the X's in half. Half goes on the right side, half goes on the base. That way we have the same base times height. Right? And again, same thing with the Y's, adding half on each side. All right, to complete this square, again, we already have 11 on this side. I'm going to add 4 more. 1, 2, 3, 4 to complete the square. Again, looking back here, that's the 4 that we added right here to complete our box. And for this one, it only takes 1 more tile to complete this box here. So we're going to put 1 more tile down here. And again, that's the plus 1 that we added here, all right? And we already added the 11 to the other side. We have the 11 on the other side. So 11 plus 4 plus 1, we're at 16. All right? And now that we have our 2 perfect boxes, all right? All right, that's for our 2 squares. This is x plus 2 times x plus 2. So x plus 2 squared. And y plus 1 times y plus 1, y plus 1 squared. Which is the same answer we had before, right? Again, setting up our square, completing the units section. All right, and again, this is going to look the same as before. Again, 16 squared is 4, right? 16 is 4 squared. Oops. All right, and again, plus 2 is moving left, plus 1 is moving down. Okay. So here, let's go ahead and go over some more examples. So again, to complete the square, I'm going to split half the X tiles, 2 on the right, 2 on the bottom. All right, and here, this also has 4 tiles. So again, 2 on the right, 2 on the bottom. Okay, and we're starting off with 1 on the other side already. So I'm going to add 1, 2, 3, 4 to complete the X squares. And I'm going to need 4 more to complete the Y squares. 1, 2, 3, 4. So now that I completed both boxes, right, I can write this as 2 perfect squares, the X squares and the Y square, equals, again, 4 plus 4 plus 1. We have 9 on the other side now. Okay, this is x plus 2 by x plus 2, so this is x plus 2 squared. This is y plus 2 by y plus 2, so y plus 2 squared. All right, so now that we have our equation, and it's in graphing form, we know what the graph is going to look like. I know that 3 squared is 9, because 3 times 3 is 9. So I can shift this plus 2, which is moving left. Plus 2 for the y is moving down. I'm going to switch it to have a radius of 3. Okay, that's what the graph looks like. All right. Here, let's go and complete the square again. So again, notice here we're starting off with -3. We have stuff on the left side. Let's go and cancel those out to the other side before we work with our completing the square. So let's move this to the other side, cancel those out. And now these are gone, let's just focus on our squares. So half goes on the right, half goes on the bottom. We're splitting it in half. Same thing with the y's. 3 go on the right, 3 going to go on the bottom. Splitting those up. Right now that we split up, we're going to complete the square for each of these. So a 2 by 2 section, notice that we need 4 more squares here to figure out the area. Right? And even though these are negative, -2 times -2 is going to be positive 4, right? So it should be positive 4 here. Here we have a 3 by 3 section, so we need 9 more tiles to complete our square. 2, 3, 4, 5, 6, 7, 8, 9. All right, now that we have our box completed, let's see, added 3 this side, plus 4, plus 9. That ends up being 16. So we have the 2 squares, the x square and the square using y's equals 16. All right, we know that 16 is 4 squared. I'll go ahead and do that now. Whoops. Okay, x minus 2 by x minus 2, so this is x minus 2 squared. And this is y plus 3 by y plus 3, so y plus 3. Oops, okay. Y plus 3. Whoops, number lock. Okay, so here, now that we have our shift, we can go ahead and graph it. Yeah, notice that when I do minus 2, it's going to move to the right. Oh, sorry, minus 2, move to the right. 2, okay. Notice that plus 3 is going to move it down. And it's going to have a radius of 4 squared, so it's going to be 4. All right, 4 squared, this is the 16 that we have over here. All right, let's go and complete the square here. Again, half is going to go down here. Half of it goes over here. And notice that on the right side, we already have 20 tiles. All right, so to complete this box, 1 by 1, this is going to be 1. 2 by 2, this area is going to be 4. 2, 3, 4. So now we can write this as graphing form. We have our 2 squares equals our, let's see, 25. 25 on the right. And this is x plus 1 times y plus 2. So now to graph this again, plus 1 means it's moving left. Plus 2 means it's moving down. And again, 5 squared is 25. 5 squared, so this should be 5. Okay. I think we have one more example right here. Again, notice that we have some extra tiles on the left side. So first, let's go and cancel those out. Add 2 to the other side. Those are going to clear out. All right, now let's go ahead and complete our square. Half goes here, half goes here. All right, we only need 1 square to complete this box. So we need 1 there. And we need 1 here to complete this box. So what is this in graphing form? We have 2 perfect squares. Oops. Equals, again, this is 4 here, or another way of writing it is 2 squared. So let's see, this is x plus 1. This is y minus 1. Oops, forgot to click over y minus 1. And now it's in graphing form, let's graph it. Plus 1 means moving left. Sorry, plus 1. Moving it down 1, or down 1 is actually plus 1. And the radius is 2. Okay, let's see. Sorry, minus 1 means moving up, sorry. All right, so, and that's how we complete the square. Again, we're splitting the x tiles in half, and then completing the box. So how do we change the equation from a circle to graphing form? To change a circle to graphing form, we need to complete the square 2 times, all right? 1 for the x terms and 1 for the y terms. Okay, so again, here the x's need to make a square and the y's need to make a square, right? Here we have 2 squares. All right, the last 2 examples are still going to be writing an equation of a circle into graphing form. This time we're not going to be using our tiles. We're just going to visualize the numbers, right? So again, if I put all the x's together, I know that half of it goes here and half goes here. And now that I have this 2 by 2 section, 2 by 2, I know I need 4 here to complete my box. All right, let's try the next one. Here we have y squared minus 6y. So y and y. Again, I have minus 3y. Again, splitting that in half. And after, sorry, I put x instead of y. Minus 3y minus 3y. Okay, and now that we have our y's, that's going to do y minus 3 times minus 3. To complete this box here, negative 3 times negative 3, we need to add 9 more tiles here. Right, and here we're starting with minus 12. So again, we don't need any of these. Let's add 12 to the other side. And now this is our right hand side. We have 25 on the right side. So setting up our box. We have x plus 2 and y minus 3. X plus 2, y minus 3. Okay. And now that we have it in graphing form, we can graph it. Plus 2 knows that it's going to move left. Knows that minus 3 is going to move it up. And again, 25 is just 5 squared. 5 times 5 is 25. So the radius is just 5. Okay. Last one. So here we have negative 8x, so half of it goes here. 4x and 4x. All right, let's see. X minus 4 times x minus 4. So get the units in the corner. 4 times 4, or negative 4 times negative 4 is going to be 16. Okay, let's complete the y's. Half goes here, so 3y and 3y. So we have y plus 3. And then y plus 3. So this is a 3 by 3 section. How much do we need to complete the square? We're going to need 9. Right, and again, I don't want this 9 here, so I'm going to subtract it on the other side. So after completing the square, we're left with this. We have our 2 squares. Two squares. And we have 16 on the right side, right? Because these cancel out. We're going to end up with 16. Oops, sorry, 16 is 4 squared. Okay, so now let's go and complete our box. Let's see, x minus 4 squared, y plus 3. All right, and now that we have it in graph form, we can sketch it. So plus 4 actually means minus 4. Right. Oh, so minus 4. 1, 2, 3, 4. All right, x plus 3 moves it down. And I want a radius of 4. All right, and there we go. All right, hope you found this video helpful, and you still have questions, let me know.